Hello, Avant-Garde students. This is Rob Jensen. I'm your owner for Avant-Garde College Prep Services, and today I'm going to be going through the May 2018 Math Section 3 for this test and helping you guys understand the individual solutions to the problems that you may have some struggles with and things. So we'll start here. What we can see here looking at number one, and it kind of seems to be a little bit more difficult than what you may traditionally see in some ways, but really it's pretty simple. It's just saying in the equation above, a is a constant for which the following values of a will the equation have no solution of things. So remember, this is kind of one of those linear constants of things within that. Well, what we're trying to do is basically say that the two sides of the equation don't necessarily agree with each other, or there's no solution for it. So the only one that will happen to work for this is answer choice A. Things, because if we put 0 for where a is, and so if we have 0 times x equals 5, then what we end up getting here is we just get 0 equals 5. So therefore we know that is not true. So therefore there is no solutions within the constant. So looking at that one. Looking at number 2, we see we have what we call just a linear equation. We're just solving for the value of x on this one. We do see that there are some fractions that are as values here. So first we need to distribute here. So 3 times 3x is going to give me 9x. 3 times 5 is going to give me 15. And we now know that side is equivalent to 2x minus 8. Looking at that, we want to combine our like terms. We need to move this over this and this over here of things. So as we do that, what we end up seeing is we have 9x minus 2x over here. We're going to have minus 15 that we're doing. So as a result of that, we're now going to have 7x equals what would be negative 23. We need to divide by 7 here. The thing, so we're going to get x equals negative 23 over 7, which is going to give us answer choice A here. Okay. Number 3, what we have is we have a function table. So primarily, remember on these things is that this essentially the h of x, the same thing as y here. And these are just ordered pairs. So what we traditionally want to try to do is attacking these is trying to solve for the slope that we may have. So this is essentially like x1, this is like y1, this is like x2, this is like y2 of things. And then, solving for the slope, the change y over the change of x. So looking at these two, we're looking at 7 minus 1 over 4 minus 2. So we're going to be left with 6 over 2, or 3 is the slope. And then from there, we can then see that the answer choice here has to be B. So we don't have to find the intercept on this one that's been given to us of things. All right, let's look at number 4 here. We see Terrence's car contains 8 gallons of fuel. 8 gallons of fuel. Are you not? Well, doesn't want to cooperate with me there. Let me see. 8 gallons of fuel. He has plans to drive the car m miles using the fuel currently in the car. If the car can drive 20 miles per gallon of fuel, which inequality gives us possible values of m. So if you think about this, really what's going on is that we have a gas tank and we get 20 miles per gallon for each gallon that we put into the gas tank, and we have 8 gallons of fuel. So how far can we potentially drive? Well, the number of miles, we know we cannot drive the number of miles that exceeds what's in the gas tank of things. And so for that reason, we can now eliminate B, because the number of miles you drive is not going to be bigger than what you have there. And the same thing here, the M is bigger than here, than the greater than sign. So B and C are gone for that reason. And then we're just sort of left looking between A and D of sorts. Well, we're trying to figure out how many miles. This is essentially kind of like a rates problem, because you see the miles per gallon, 8 gallons per fuel. So we know we want to be left with miles here. So if we try to solve for this, we have the 8, which is 8 gallons. And then that's being multiplied by 20 miles per gallon, right? So the 20 there, looking at that, so that's going to be 20 miles per gallon. Well, if you look here, and what happens is if you multiply these two terms, you're eliminating the gallons and you're left with miles. And so therefore we see that A is the answer choice. Well, D here, what you're saying is that that is 8 gallons is greater than or equal to 20 miles per gallon times miles. And you can see that this does not agree here. As you look at things, you know, if you multiply across, you're going to get miles times miles, and then over. So that's just going to leave you with miles squared over gallon, which does not agree with the gallon unit that you have over here. So D is largely eliminated because the units don't even agree here to things, where on this side we have miles is less than or equal to miles. You see this is connected to this. If you need help sort of eliminating for those reasons. Okay, let's look at number 5 here. We see this is an angles and lines question. Remember angles and lines. This is angles and lines. And traditionally in these problems, you're going to be tested over like vertical angles, remember, supplementary angles, Z transversals of things on this one. And we see that when we see that line, that word there, parallel, when we see the word parallel, that's normally going to indicate that we're talking about Z transversals. Okay. And if you remember about Z transversal, essentially we have two lines, a transverse line going through it. And in that you have a Z, which you can draw where the inside angles are agreeing with each other and the outside angles are agreeing with each other just as well. As we look at that of some sorts. And the same thing up here is we want to kind of see Z transversals appear. So in the figure above, line T intersects line L and K. We see that's the transverse line, which the following statements, if true, would imply that lines L and K are parallel. Well, looking at the first one, W and Y, and we look at that and we know that they are congruent with each other. We see that. That's suggesting that there are vertical angles. So yeah, that's vertical angles, but that doesn't necessarily tell us that it's parallel. We can have vertical angles with any set of lines that sort of cross each other. So A is not it. Now W and Z, so looking at that is in this, we can see we have, you know, as we try to draw our Z in here, things. So W and Y, Y is on the outside of the Z, so that would suggest that would be this here. And then for vertical angle rules, and Z would be congruent to what we have here. And so looking at this, W is and Z are the same angles, and they're true, so you can see that. And so for this one, this suggests that because of the Z transversal, B is the answer choice on this one. The things X and Z would not even be true, and X plus Y equals 180. That is indeed true, but again, that doesn't necessarily suggest, just because it follows the rule of supplementary angles, that it is the two lines are parallel. Okay, let's look at number 6. What we see here immediately is we have a formula here, right? And then we see this in terms of, right? So that screams to us that this is what we call an RAE, or rewriting algebraic expression. And so all we're trying to do is take this original expression and rewrite it in the term of H here. So let's copy down what we have up here. So VB equals VP over 1 minus H of things. And we want to solve for H. So one of the things I can try to do here is I can treat the whole bottom as one thing and then multiply by 1 minus H. And then I'll do that to the other side too of things. I'll do that over here. That would be 1 minus H and such. You know what? I don't really like that. I can do it like that, but I don't really like it like that. You know what I'm going to do is I'm just going to flip this thing around. So VB is equal to VP over 1 minus H. And so what I'm going to do is essentially I'm going to make that like in a fraction and flip these things around upside down. So what I'm going to be now left with is 1 over V over B equals 1 minus H over VP. Now what I can do, which is a little bit simpler because I don't have to sit there and distribute this thing into the others, is multiply by VP, and I'll multiply by VP over here, which then puts that into the numerator. So I know VP has to be on top, so immediately I can eliminate V of sorts on that one. And VB is on the bottom, so that D does not look like a good answer choice there. So as we continue, we've got VP over VB equals 1 minus H. So now what I can then do is subtract by 1. And so everything over here, I will subtract by 1 over here too. And then what you'll then notice is that sorry, struck out too much. The 1 is gone, right? And so now I'm left with, I'm learning out a little room here, VP over VB minus 1 equals negative H. Well, then I need to distribute the negative here. So I need to divide by negative 1. And so that's going to change all these terms, make that instead of minus 1 a positive 1. And so we see that is right there. So C is the answer choice and not A on that one. Okay. All right, let's look at the next one. What we see is this is what we call a rational equation. All right, a rational equation. And we see that we have these variables in fraction forms. And we're just solving for the value of x here. Well, one thing to realize here is that we have this x plus 5 and this x plus 5, right? And this equal sign. So what I can then try to do is I can pull this to the other side. Okay, pull this to the other side. And so now that's going to give me 2 times x plus 1 over x plus 5 plus, because over here I had to, since that was minus 1 plus 5, I have to add 1 over x plus 5 to get rid of that. So that's going to be 1 over x plus 5 equals 1 of things. So then I got to distribute. So that's going to give me 2x plus 2 over x plus 5 plus 1 over x plus 5 equals 1. And then as you see, I have a common denominator here, so I can then add these terms together. And so as a result, I'm going to have 2x plus 3 over x plus 5 equals 1. Now, what we can then do here is essentially this 1 is basically 1 over 1. All right. And as a result of that, what we can then do is we can treat this right side, as a fraction of 1 over 1. And since we have an equal sign, we want to cross multiply and divide those terms. So I'm going to move all this over here. Okay. So now I've got x plus 5 times 1. So that's just going to give me x plus 5. And then 2x plus 3 times 1. That's going to give me 2x plus 3. Solve for x. So I'm going to move the x over here. Then move that over there. So that's going to be minus x minus 3. So I'm going to get 2 equals x. And so therefore my answer choice on this one is going to be B. Okay. Now, if you sort of struggle with this, now remember what we can always do is we can use trial and error here. And essentially what you can do is you can take these answer choices and plug them into where x is into each one of these, and the two sides should agree with each other. So if you struggle with rational equations are really good problems on either A, making numbers up to solve for and simplifying the expression, or if you have values like you do here, you can use trial and error and just take those numbers, pop them in upstairs into the value of x, and seeing which one produces the equations where the right and left side of the equations agree with each other. Okay, let's look at number 8 here. Okay, Now, number 8, what we immediately see off the bat is we see these signs right here, right? And so what that is suggesting to us, this is a quadratic formula question. Okay, so even just looking at it, before I even start, I know, okay, yeah, I have to use the quadratic formula because I see the answer choices. And remember, with these quadratic formula, you will always be prompted to use the formula. You just never randomly use it. You'll see it in the answer choices, okay? So keep that in mind. So we want to identify our ABCs. We want to get everything onto one side, so I need to move all this over. So that's going to give me 2x squared. That's going to give me minus 2x, okay? Because I got to do that. And then here, that's going to be minus 3, so it's going to give me minus 5 equals 0. So here are my ABCs. So you can see the A value of my quadratic equation is 2. The B is negative 2. And the C is negative 5. So my formula, negative B plus or minus B squared minus 4AC. Take the square root of that value over 2A. I'm probably going to get really tight on space here, so I'm going to try to make it work. So I'm going to have negative 2 plus minus negative 2 squared. I'm going to take the square root of all that. Minus 4 times 2 times negative 5. And that's all going to be over 2a. So 2 times 2 is going to give me 4. All right. Now negative 2, that's going to give me 2. That's going to be a positive 2. Now, one of the things I'm looking at immediately, and I'm not sure which answer choice it is, but I'm gathering it's either C or D, because the 2 over the 4 here, as I solve for this, the 2 over the 4 is reduced down to 1/2. Typically, you have to splinter those terms up. So I'm guessing it's either C or D right now. Don't know for sure. Let's just continue to work it out. So taking, that's 2 plus or minus 2, negative 2 squared is going to give me 4. Negative 4 times negative 2 is going to be negative 8. Negative 8 times negative 5 is going to be positive 40. So it's going to be positive 40 of things. So then that's going to give me 2 plus or minus the square root of 44 over 4. Let me try. I'm running out of room. What I'm going to do is I'm going to come down here to help solve. I don't think I need all the room up here. So I want to splinter this thing up. So I'm going to recopy it over 4. So now this is going to splinter into 2 over 4 plus or minus the square root of 44 over 4. That's going to reduce down to, all this is going to reduce down to 1/2 plus or minus. Square root of 44, we can pull that out, and that's going to be the product of the square root of 4 times the square root of 11 over 4. So square root of 4 is going to reduce down to 2 times the square root of 11 over 4. This is still 1/2. That's going to reduce down to 1/2. So that's going to reduce down to 1/2 plus or minus square root of 11 over 2. So looking at it, D is the answer choice because we're both over the square root of 2. So looking at this, D is the answer choice on this one for number 8 of things. Now remember, when you're solving for quad formula, these problems are almost always going to be in section 3, asking you to go through the calculations of things as you try to solve for this and such. If it is in section 4, it's very, very rare that may ever happen. But if it is, then you can use your calculator to just pop in those values of A, B, and C in there and spit it out without having to do any calculations for the answer choices. Okay, looking at number 9, this is a polynomial, and we're trying to say which of the following above is not a factor of the polynomial. And so as we try to simplify these terms, we know we can pull an x out of all these. So now we're left with x times 2x squared plus 11x plus 5. The other thing here is I'm trying to figure out, so we know it can't be a, because a is one of the factors there of sorts. So we need to work on trying to factor this, and so finding our two binomial terms that would agree with it. Well, we know this is a prime term too, so we know that one of them has to be 2x, I think, and this has to be x, and so that is a 5, so really we only have 5 and 1 that will come off that. So what will give us 11? Well, plus 5 here, so 2, and plus 1 here, so 2x times x is going to give me 2x squared. 2x times 5 is going to be positive 10x. That's going to be positive x, and that's going to be positive 5. So this statement up here agrees with what I have right here. So 2x plus 1 is a term, x plus 5 is a term, so that means d, 2x plus 5, is not a term of the polynomial above. Okay, looking at number 11, we see we have a function. This is actually a coordinate geometry question. Anytime that we see anything that's in the xy plane, okay, that's a coordinate geometry question. Okay, coordinate geometry. And it's saying that the linear function that contains a point 3,4. So we know that is a solution to the function for every increase of 5 units. So as it talks about an increase of 5 units, in x, so that is saying f of x, or essentially that is y. Remember, f of x, same thing as increases by 3 units. Now remember the slope. Okay, remember the slope is equivalent to the rise over the run, which is the y value over the x. Well, if f of x increases by 3 units, that is saying that's the y there. So that's 3. And then increase of 5 units in the x, that's my run there. Okay, that's my run. So that's 3/5 is my slope. So honestly, I don't necessarily need to do anything more beyond that, because that's not it, that's not it, that's not it. And I can see C is the answer choice on this one. All right, looking at number 11, we see we have another function table here, and it's a polynomial function for what we see on this one. And so what essentially says, based on the values in the table, which of the following must be a factor of p? P is a function, right? So what this is essentially saying, really, this is just saying we have some sort of p of x equals some term of x plus m and x plus n. Now remember, these are factors. These are factors. And what do we know about the factors is that when graphing these things, okay, when graphing these factors, all right, essentially we have intercepts, right? So when y equals 0, remember, when y equals 0, we have these x-intercepts. They're right here. So essentially, we are, as we say this, looking at this, this is what this is trying to say. When y equals 0, what is the value of x? Well, we see that in two different spots here on this one. We see here the y is 0 right here and here. And it's saying that the x value is -1. Well, remember down here that when you are solving for the 0, this ends up being like x equals -m and x equals -n are the rules. So in order to make that into a factor, that is saying x equals -1 right there. First one is saying x equals -1. Well, we have to move that back over. So really that is x plus 1 equals 0. And then right here, that is just saying x equals 2. And again, we have to move it back over. So that's saying x minus 2 equals 0. I think. So these are our polynomial or our factor terms, x plus 1, x minus 2. So D is the answer choice on this one. Okay. Okay, number 12. We see this other function. We see we have this this being raised to a power here, right? That says 2 to the x power minus 2. And it's saying the function g is defined by the equation above. Which of the following points in the xy plane is an x-intercept of the graph of the equation y equals g of x? Well, if you remember, think about it. This is, so you see the intercept here is at, well, really the, what we're saying on this one which of the following points in xy plane is an x-intercept? Well, the x-intercept, that's along this line here, right? That is saying that y equals 0 for the x-intercept, okay? As this thing sort of crosses here, as this thing sort of crosses or whatnot, we know that the y equals 0 there. Let's see here. So let me double check on this one. 12. So when does this thing equal 0 is what we're saying? Okay, hold on a second. Okay, so if y equals 0, then really rewriting this problem, okay, I know what I'm doing now. Okay, g of x equals 2 times x minus 2. We're saying that if y equals 0, g of x is the same thing as y. So we're saying that 0 equals 2 to the x to the minus 2 of things. So if I move that over, that's going to be 2 equals 2 to the x. Well, when does x here, okay, give us that value of 2? Well, we can see that it had to be raised to the 1 power if we put 1 in there. So 2 equals 2 to the 1 power. That is indeed true of things. So we're saying when x equals 1, g of 1 is equals 0 here. And so that is the answer choice on this one is C on this one of things. If you try to do anything else here, if you put, say, -1 where the x is right there, right? If you put, if I said, to the -1 minus 2, that would not be equivalent to 0 things, because that 2 to the -1, that's basically saying that's into the negative term, so that's saying that's 1/2. So that's saying like 1/2 minus 2, which that again is not equal to 0 of things. 0 there, if I put 0 up top, so if I put 2 to the 0 minus 2, again, that is not equivalent to 0, because 2 to the 0, that's just saying 1. Anything to the 0 power is 1. And again, that is not an agreement there. And the same thing, 2 squared, that wouldn't give me that either thing. So C is the answer choice that we're looking for on this one of things. All right. Looking at number 13. Oh, looks like I'm missing a portion of that. All right, let's resume with question number 13 on this test and what we're trying to accomplish here. We see that we're graphing a polynomial here, quadratic equation of some type. A couple key things. We see that we have a negative, so that means we've got a parabola that's going upside down. So immediately we can eliminate A and C, since those are happy ones of things. And the other thing about this is what we can see here is that there's no constant term here. So normally if you have a C, that there's going to be the y-intercept when x equals 0. Since there's no constant term there, that means really that's going through the origin of 0, 0, which we see that's happening here, things, because that would suggest that right there, that would suggest that we would have a +5, which that is not the case of things when x equals 0. So B is not the answer choice, and instead D is the proper answer choice on this one. Okay, number 14. We're dealing with the complex numbers and these imaginary numbers. Keep in mind here on these imaginary numbers that remember I to the 1 is just equivalent to I, or the square root of -1. I squared is -1. I cubed is -I. And I to the 4th is just 1. So this says, as we read here, I squared, and then it says in a complex number, what is the value of the given expression? So we have I squared, and it looks like it's being multiplied by -I squared here of things. Double checking, but that should be I squared times -I squared. So I squared here we know is -1. And then here what we have is negative I times negative I, right? So because that's being squared, right? So negative I times negative I, that's going to give me a positive I squared. So that's just going to be I squared of things. I believe something is missing from this one. I believe there's supposed to be a positive sign in there. I'm not sure why that is missing. Because I squared is also negative 1. So I have negative 1 plus negative 1, which gives me negative 2, which gives me the answer choice on this one is A of things, 14. Yeah, I think something is missing on this one of things. Yeah, because otherwise, negative 1 times I squared is just negative 1, so that's negative 1 times negative 1, which gives me just 1, which that's not the answer choice, or even an answer choice here. So there has to be a plus sign in here. I think that the copy of the test did not necessarily go so well at that point. So, okay, number 15 here. It says dimensions of the right rectangular prism are 4 inches by 5 inches by 6 inches. What is the surface area? So here we have to be very mindful of what is the surface area in the square inches of the prism. So if we draw, right, our prism here, right, draw this thing out real quick, and we know we got kind of do that. So if it's 4 by 5 by 6, so let's say this is 4 by 5 by 6. So what we can then see is that the two sides, right, 5 times 4 is giving me 20 on the sides of this thing. So we've got, so the sides are 20 plus 20, which is 40. The top and bottom, so if we do the top and bottom, right, so the top would be 4 times 6, so that gives me 24, the top and the bottom. So that's going to be 48. And then the front and back of this thing would be 6 times 5, which would give me 30 for front and back. So that'd be 60. So if you add up those values, you get 8, 148. So you get D as the answer choice on that. So you're adding all the surface sides together on this one. Okay, number 16 here. We see we have a system. We want to know what the value of y is on this one. What is this? Is the solution to the given system? What is the value of y? So it means we want to eliminate x. So we do substitution here. We just put this 2 into where x is. So now that's just going to read 3 times 2 plus y equals 29. So that's going to give me 6 plus y equals 29 minus 6. We get y equals 23 as our answer choice on that one. Okay, looking at the next one, it says a pizza parlor sells pizza slices for $3 each. Sells pizza slices for $3 each, and calzones, so pizzas are going for 3, calzones are going for 4, setting up like a system of equation problems. Group of friends spent $51 on pizza slices and calzones at a parlor. If they bought 6 calzones, how many pizza slices did they buy? Well, as we try to construct this, we see that pizza is equivalent to $3. The calzones is equivalent to $4. They spent a total of $51, right, of things. And they bought 6 calzones. So here we can write the equations. Let's see here. We do not know how many in total they bought. That's not given to us. So if we write 3 times P plus 4 times C equals 51. We do know that because that is, you see the relationship and how these two tie to this. And then we have some x value of P plus 6C equals some unknown value here of how many they bought. Okay, so a little bit of an incomplete here. Oh, well, we know they bought 6 calzones, so we can put the 6 right there, actually. So let's complete this. So that's going to be 3p plus 4 times 6 equals 51. And that'll help us solve for the number of pizzas there. So that's going to be 24, so minus 24. So 3p equals, what is that going to be? 26, 27. Yeah. So divide by 3. So I get p equals 9. So yeah, I get pizza equals 9 there. So not a complete system of equation, really. It's kind of more of a linear that we have to solve for things. Okay. Number 18, we see we have this quadratic word problem. It says if the air resistance is ignored in the function h defined above models, the height above ground in feet. So we see feet, so h of t there is in feet. Of a toy rocket t seconds, so t equals seconds after it's launched from the reported basal model. What is the height above ground in feet of the toy rocket 1 second after launch? So really, we're just saying t equals 1. So what is h of t, or in feet, right? So taking that, plugging that in, we have the equation h of t equals negative 16 t squared plus 48t plus 70t. So wherever we see t, we're just plugging the 1 in right there for those two. And as we solve, we're going to have negative 16 times 1 squared plus 48 times 1 plus 72. That's just going to be 1, right? So it's going to give me negative 16 plus 48 plus 72. As I add my terms here, negative 16 plus, add the 8 to that, it's going to give me 80, 120, and so h of t equals what? 104 for that one. Easy enough. Just plug it in negative 1 for, or it's probably just plugging in 1 for t for things. All right. Number 19. So we see we have a linear equation that's being graphed on what we have here. Looking at this on this this coordinate plane, it says that says the points plotted in the coordinate plane above represent the possible numbers of wallflowers and cornflowers that someone could buy at the garden store and to spend exactly $24 total on the 2 types of flowers. So we know that we're buying wallflowers plus cornflowers equals $24, right? The price of each wallflower is the same and the price of each cornflower is the same. What is the price in dollars of 1 cornflower? So we want to know what 1 cornflower cost of things. Well, the easiest thing we can do is take our intercepts here. Here is the same number of cornflowers, which this is the same thing as x. This is the number of wallflowers, same as y. And we want to solve for cornflowers, which is essentially x here, right? So on here, at this point, we see that is 0.160. So that's saying regarding cornflowers, or x, we have 16. And the wallflowers, we have 0. So if we then use these values to plug into here, right? We use these to plug into here. The equation would then read 16. I'm sorry, not 16. Plugged them in the wrong spot. Instead, 16 will go here, and this will go right here. So now writing it, I would then have 0 times the cost of wallflowers plus 16 plus the cost of the cornflowers equals 24. Of course, that gives me 0 there. So now I have 16c equals 24 divided by 16. So I get c equals $1.50 as my answer choice. All right, number 20, we're talking about fractional and negative exponents. We want to know if the square root of 5 over the cubed root of x to the fourth is equivalent to a over b here. So remember, we want to always divide and conquer these things. Taking the first half, that is the same thing as x to the 5 halves over, and taking the bottom here, that's going to say that's going to be x to the 4 over 3, right? Because that's power over root, right? So as we do that, and we know this is equivalent to x to the a over b. Well, we want to then move this from the bottom. We want to conjoin our x terms into the top, and so share the same basis. So what we then now read is that we have x 5 halves, and then now since that's 4/3 in the bottom, it now turns into negative 4/3, right? And we're adding these terms here. So we're adding these terms as a result of that. So this is equivalent to x to a over b of thing. So now that we're adding these terms, we have to treat them like fractions. Remember, in order for that to happen, we have to have a common denominator for us to add these fractions. So the least common denominator is 6. So the first one is going to change into, I got to multiply by 3 on both top and bottom, so that's going to give me 15 over 6 plus, that's going to be multiplied by 2, so that's going to give me negative 8 over 6. Okay, and so now that I have a common denominator here, right, I can now I can now combine, which is going to give me x over, is that 15 minus 8 is going to give me 7 over 6. So, and so that's my answer. My grid in is going to be 7 over 6. That's the answer, because that is equivalent to a over b there that we see up here. Okay. All right. Well, thank you so much, and we'll see you in section 4.